Okay, John, I'm gonna skip over all the sequence stuff here and get right to the summations, okay? So you can look over the sequence stuff, and I think it's pretty much self-explanatory, and let me know if you have any questions. In regards to summations, okay, which is down towards the bottom, okay, you can read the notation if you have questions on the notation, but I'm going to get right to walking you through some problems and pointing out a few key things to keep in mind, okay? So, right off, you have three formulas that I think you really should have memorized, okay? And these are, I guess, three special cases which come up and are applicable in a lot of problems, okay? And the first one is the summation of a constant. So I'm looking at this one here, the summation of a constant. So the number C is a number, like a 5 or a 4, all right? When you have a summation of a constant, and you're starting at 1 and you're running up through n, okay, then that sum adds up to C times n, all right? So, for example, suppose I have 1 to 10, and I have a 5 here. That's a constant. In other words, the index k or I or j doesn't appear here on the right-hand side. Then the answer to this is 5 times 10, which would be 50. Okay, I'm going to erase this. Here's another example. Suppose I'm looking at this sum here, 1 to 7, or maybe a minus 4. Again, notice the index, whatever the index, again, is some letter, usually K, I, or J, doesn't appear here on the right-hand side. So in other words, this is simply a constant. Then this would be minus 4 times 7, which would be minus 28. All right, so I'm going to move on to the next formula. When you're summing up the index itself, whatever that index is, when you're summing up the index itself and you're going from 1 to n, here's a formula that you can use. So here's a couple of examples of that. Suppose I have a sum, and I'm going from 1 to 5. Again, and suppose this is an I. Again, the index can be an I, a J, or a K. It doesn't really matter. So I'm summing up my index, right? So the formula tells me that this is then going to be equal to n times n plus 1 divided by 2. In other words, this is going to be 15. So if I go 1 plus 2 plus 3 plus 4 plus 5, that adds up to 15. See, 9, 12, 14, 15. I'm going to erase it. Suppose I have this example, okay? Suppose I have this example here. Summation 1 to 15 of I, okay? Then the formula would be, okay, so anyway, in this situation here, Hal just calmed me down. That's why I'm acting as though I might not know where I'm at. So again, we're adding up the index. So 15 times 16 divided by 2. And so you clean this up and whatever number you get. Then there's another formula. And that second formula is when you're squaring the index. And so if you're squaring the index, and again, you have to be careful that summation's running from 1 to n. They could throw a little curve at you. Let me just kind of point that out. Suppose they asked you to calculate summation maybe 5 to 1,000, right? See, this summation starts at 1. So you'd have to manipulate or do a little trickery here to work with the formula. In other words, what I'm saying is, basically, that would be equal to the sum from 1 to 1,000 minus the sum from 1 to 4, you see? That's how I would deal with that scenario, where if I started off at 5 and ended at 1,000 of I, then I could calculate it from 1 to 1,000 using the formula, calculate it from 1 to 4 using the formula, and then that's got to be the difference. So you have to be careful that starting point is a 1 and it stops at n. Now, I'm going to skip this over, so let's not even think about this. Skip this over, don't even think about it, okay? Let's go to the next formula. This formula is useful in the problems below. Okay, so what I have here is I have a sum starting at 1, ending at n. There may be a constant number in the front. And then you have another number being raised by the index. See here, R is being raised by the index. So here's an example of that. There's an example of it. Here, my constant would be 3. The value R would be 1/2. And then I would plug it into the formula. And the formula would say 3 times 1/2. 1 minus 1/2 to the 5. All that divided by 1 minus 1/2. And you'd have to clean that mess up, okay? Which I'm not going to do here. I'm trying to explain the formula to you, okay? But again, here's a formula. Again, I would have it memorized because it's a very useful formula. But once again, the formulas you have to be aware of, they have to be in that certain form. So I'm trying to erase everything for me while I'm talking to you. All right, so here's another example. Suppose I have summation 1 to 17, and I have 4 to the k. Now in this case, the c is a 1. C is just some number that's in the front. Sometimes you don't have anything. So c is just a 1. R is a 4. So c is 1. R is a 4. So here's the formula. 4 times 1 minus 4 to the n, which is 17. All that divided by 1 minus R. Again, you could clean this up using your calculator. So, these three formulas are kind of critical to have memorized. So, I'm going to go right down to the problems, right here. Okay? Go right down to the problems and just start looking at a few of them. Alright, here's a summation j squared. Well, once again, I had that formula, summation j, and the index squared, and what was it? Index squared, oh, I'm passing it up. There it is. 1 to n times n plus 1, 2n plus 1, all divided by 6. So, this problem here would be n, which is 5, times n plus 1 times 2n plus 1, all that divided by 6. So 5 plus 1, 2 times 5 plus 1 divided by 6. And then you add that up. Okay? So let me erase. Okay, for number 2, John, this is something that you keep in mind too. If you're working a summation and the number of steps is just very small, it's probably best if you just work it out. In other words, I start off at 5, then 6, then 7. When I plug in a 5 here, I get 16 over 25. Plus, when I plug in a 6 here, 18 plus 1 is 19 over a 36. Then I plug in a 7, 21 plus 1 is 22 over 49, and I would add all this up and get a number. Okay, so you see, if the number of steps you have to do is very small, why not just start plugging it in and work with the basic definition? Okay, so I'm going to erase this. Okay, now when you have a double summation, here's a nifty little trick here. Okay, I'm going to make a table here. And I'm going to make a table. I'm going to have the I values listed down here. So I is going from 4, 5, 6, and 7. And then J is going from 1, 2, 3. Okay, 1, 2, and 3. And the calculation is I over J. So here's I, and here's J. So I over J, 4 over 1 is 4. 4 over 2 is 2. 4 over 3 is 4/3. Then 5 over 1 is 5. 5 over 2 is 5 over 2. 5 over 3 is 5 over 3. Then 6. 6 over 2 is 3. 6 over 3 is 2. Then 7. 7 over 1 is 7. 7 over 2 is 7 over 2. 7 over 3 is 7 over 3. And then I add all these things up. So that's probably, you see I made this little table here. That's probably the fastest way to do a double summation. And then I'll look on the inside of this to determine how these are going to react, okay? So if I add all these things up, these rows across up or the columns, just add all this stuff together and you'd have your answer there, okay? So there you go. I'm going to erase this. And I could actually, let me show you another one. I'm going to erase it and come up with another one. Okay, so here's another example of double summation. Okay, so once again, I'm going to make this little table here. I is going to run from from 3, 4, and 5. 3, 4, and 5. J is going from 1, 2, 3, and 4. Now it's telling me to multiply them. So 3 times 1, 3 times 2, 3 times 3, 3 times 4. 4 times 1, 4 times 2, 4 times 3, 4 times 4. 5 times 1, 5 times 2, 5 times 3, 5 times 4. I'd add all that up and that's my double summation. Okay? Alright, so next one. Let me erase this. Okay, now for 4, you notice you have 3 summations, okay? So this is going to have to, I'm going to have to do something a little bit differently. So what I'm going to do is I'm going to list k equal to 1, and then the next one would be a 2, and I would repeat this going down if there was a 3. Now over here, I'm going to make a table with the I and j like I did before. Okay, so this would be I, and this would be j. I is going from 1 to 2. J is going from 1 to 2. So again, if I was going from 1 to 4, then it'd be 4 here. If J was going from 3 to 4, 3, 4, right? Okay, so now I am multiplying I times K, then dividing by J. So K times 1 times 1, divided by 1 is 1. 1 times 1, divided by 2 is 1/2. 1 times 2 divided by 1 is 2. 1 times 2 divided by 2 is 1. Okay? So then I will go down to the next one. Rebuild this table. I and then J. In a similar fashion, it's I times K divided by J. So 2 times 1 divided by 1 is 2. 2 times 1 divided by 2 is 1. 2 times 2 divided by 1 is 4. 2 times 2 divided by 2 is 2. Then I would add all these little numbers in the boxes up, and that would be my summation. So again, if K happened to be going to 3, then I'd put a 3 down here. So this is a nifty little trick to make it a lot easier to calculate these, okay? So look at this little table thing. I'm sure he's going to probably, knowing many math instructors, they like to throw that kind of stuff out there on you. Alright, I'm going to erase this. Okay, for this one here, number 5, none of my 3 formulas really apply to this, okay? So, again, it isn't really that bad. It goes from 1 to 6. So 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6. And just add that up. Just grit your teeth and add it. Okay? If they're not that bad, don't try to come up with some sort of creative number there. Okay? Alright, for this one here, okay, 1 through 4, again, since the range is so small, I would just simply start plugging numbers in. 1 over 3, 2 over 6, 3 over 11, and then 4 over 18. And then just add them up, okay? Now, John, let's look at number 8, okay? Now, I'm assuming you really should have parentheses here, okay? Whenever there's a minus sign in there, there's a good chance that there is a pattern going on. So it's good to try to recognize the pattern and think about it. Start writing them down. 1 over 1 minus 1 over 2. So that's 1. Then going to 2, 1/2 minus 1/3. Going to 3, 1/3 minus 1/4. And then you're going to be all the way to 30, which is going to be what? 1 over 30 minus 1 over 31, right? Notice the inside things are all canceling, and so your answer is going to be 1 minus 1 over 31. So whenever there's a minus sign in there, there's a good chance that they're setting up a pattern where certain things are canceling out. Well, in this one, everything on the inside is going to cancel, okay? Because for this 30 here, in the previous one, there was a minus 1/30, okay? So that's the idea behind that. You don't have to work it from 1 to 30. See, these here, there's no subtraction going on. And so the only other thing I could see here, well, I can't say, I think you work with these just like they are. You could spend forever trying to figure out the pattern when you only have 6 steps or so many steps. Just get to work on it. All right. So let's move on. I'm gonna skip this right now. I'm gonna produce another video on this one here for you. Let's go right to some more summation problems. Okay. All right. All right, our third formula, remember the geometric formula, was when you had the index as an exponent. Well, here it is. This is that case where we have summation, 1 to n, some constant, and our number raised to the index, right? And our formula was c times r, 1 minus r to the n, divided by 1 minus r. So in the very first problem here, c here is equal to a 1, r here is equal to a 2, and n is equal to a 10. So you'd plug it in, 2 times 1 minus 2 to the 10, divided by 1 minus 2, which is a minus. And so you get your calculator out and calculate that. I'm going to erase it. Okay, here's the next one, John. This one's a little bit more trickier. This is really summation 1 to 60, 4 over 7 raised to the j. Since, again, I'm working with this as an exponent, my formula, c is equal to 1, r is equal to 4 over 7, and n is equal to 60. So, 4/7 times 1 minus 4/7 to the 60th power divided by 1 minus 4/7. Now, I just realized that they didn't want the actual number, they wanted to find a formula. So I guess, in other words, you can actually stop right there, okay? You could physically stop right there because of that formula, all right? All right? So, even in the previous one where I said you could clean it up, well, I don't know. Maybe you could clean it up, but you could actually clean this up and get an actual number. For number 20, I'm not going to do 21. They'll get that bad, then it can get very complicated. For 21, this is my suggestion. Take 5 to the j, and then write the bottom part as 2 times 2 to the j. Exponent, when you multiply, you add exponents, right? So this is really 1/2 5 over 2 to the j. So in this situation here, you do have a value for c, and r is equal to 5 over 2, and then you're starting off at 4, as opposed to 1. So you're going to have to do 2 summations on this one. These two get messy. So that's why I'm saying in a way, hopefully he won't do nothing like that. He'll probably give you something like these right here. Okay? But sometimes it does require a little trick. You see how I worked with this? And if it was a 1 to 31, if it was a 1 to 31, then it would be C times R times 1 minus R to the 31st power, all that divided by 1 minus R, right? And see, these are messy to calculate, okay? But you see, if you calculated this one here, then you could actually do that thing I did earlier where the summation from 4 to 31, sorry, that's supposed to be a 31, would be that one minus the summation from 1 to 3. Okay? So that's it for the summation. I'm going to come back later and get you something together for these other ones right here. Okay?